Hey everyone.
Hello.
Oh,
Hi.
All right. So right now we have 3 items on the agenda. John, you don't have an item on the agenda this week. You want to go ahead one?
Yeah, we do.
I don't see-
Mihai was great. Yeah,
Okay.
we probably didn't add it.
Okay.
I think Mihai wanted to talk about his progress, but he's having trouble getting in, so trying to.
Okay.
I'm in. The link you sent me was fine. Hello.
Okay,
all.
great. All right. So then let's get started. First we have, let's see. We want to talk about the WebAssembly OCI spec. There was an announcement that we made last week. We had started work with WebAssembly Hub, and then as part of that, there's an image artifact specification related to how those modules are stored. And the metadata related to them. So, and that's something we wanted to make as a broader community discussion so that the specification could apply to any sort of WebAssembly module beyond, our use cases mostly Envoy, but could it be something that's, if we get the right set of things in that spec, it could apply broadly. And then that way there's, there's compatibility in registries and such. So let's see, who do we have from our side on the WebAssembly? Shane's here. Shane, you want to talk about it a little bit?
I'd actually probably give that one to Scott.
Oh,
OCI
Scott,
is kind of
yeah.
his baby.
Okay.
Yeah, should I go now or?
Yeah, if you want to describe it a little bit more in detail, and then the kind and where we would like community input so that we can kind of make sure that the spec addresses,
Sure.
more, the module types and where we'd like community contribution.
So to give those of you guys who don't know a little context where we're coming from. So you guys do probably know or may have heard of the OCI spec, which is the Open Container Initiative image spec. It's basically a descriptor for, or it's a specification for how to package a tarball such that it can store originally Docker containers, but really it's like a layered file system where you have layers. It's like the tarball is stored as a set of layers. Each layer has a commit SHA and a descriptor that describes what's in it. So they can really be used to store anything. Originally, this is how this was built based on Docker, and it was specifically for Docker containers. But we've seen other usage start to get adopted in the cloud space. The other use case that I'm aware of is people using it to package Helm charts and distribute Helm charts. But it's all the niceties of the way that you build and ship a Docker container. So you've got a checksum, you can use caching, you can use a Docker daemon actually to store it, or something like Harbor. You can use an image repository to store, version your images. And it's just a very convenient way of distributing really any kind of assets that are going to your cloud workloads. So everything can be done with this declarative configuration and so on. So the OCI image spec is there, and it describes how to store anything as an image. And then what we did, we built on top of it a WASM image spec. And we're basically leveraging OCI. It's built on top. So OCI gives you, it basically it tells you what the content of a layer is in terms of you have a descriptor and the actual bytes that make up a layer. We're specifying what actually goes in the descriptor and what goes in the layer, specifically as a means of packaging and distributing OCI images that contain WASM modules. So we had this problem with Glue where we wanted to allow Glue and eventually other systems. That's why we have tooling around it called WASMI. But there's a whole solo.io WASM repo right now that you can check out. But part of the repo is about building and distributing WASM filters for Envoy. And so that has purposes, that has applications in both, really in all of our projects. But specifically in Glue, we had this use case where we're like, okay, we want to allow users to leverage WASM inside of Envoy and provide a convenient way to ship them, because it's compiled code at the end of the day. So it's an artifact and you need a way to distribute that. So we basically built tooling around it. And when the tooling, rather than just hard coding some implementation inside the tooling, we actually built out a specification that works well for, I would like to say, for the general distribution of WASM modules. It's not just specific to Envoy. Like, we can go into the actual details of the spec, but it's basically designed to say, okay, we understand that WASM is becoming a really powerful tool on front end. It's becoming more and more adopted for back end use cases, like Envoy is a great example. We've also talked about using it to distribute GraphQL modules. There's really a lot of applications there. So we wanted to basically put something down that would be useful to the community, that we could get some consensus and convergence around. So definitely, we're looking for feedback. We should add the link to the spec in the doc if it's not there.
Yep, I did, and I also put it in the chat. I don't know if we want to just show what's all in there or not.
But the main points of the spec are that the image consists only of a simple of two layers, one that contains the module binary itself and another that contains a config file. The config file is JSON that is expected to be loaded by an OCI, a spec compliant runtime. So there's this concept of runtime. When you have a WASM module, it's always being run by something. So in Envoy or a browser or Bazel, I don't know. I don't know who outside of these use cases, different runtimes that exist, but there are many. And so you'll have a configuration file that describes certain properties that are common to every WASM module, such as the version of the interface that they're built for. I need to take a look at the spec and refresh my memory. But then there's also an opaque part of the configuration that's for the runtime itself. So in Envoy's case, that would be configuration for Envoy at static configuration that it needs to be aware of in order to load this module. And so when you build a WASM module, not only are you able to build the binary, but you can also build, as part of the image, some configuration parameters that otherwise your users would have to hard code or keep track of somewhere. So yeah, I encourage you guys to check it out and look at some of the tooling that we're building around WASM. I think it's still very early, but it's a really powerful way to handle distribution of any kind of artifacts in the cloud, not just limited to Docker containers.
Hey, thanks. There's a guy in my group that's doing a lot of work with WASM stuff, so I forwarded that on, get any insights he has.
It'd be great to have him join one of the community meetings.
Well, he has. His name is Dominic. He's kind of diverted away from Service Mesh Hub specific stuff. But since you've changed the community focus, he might be interested in kind of joining again.
I miss all of Dominic's questions. We need him back.
It would also be great to get feedback from people who are actually working with WASM today on the spec.
Cool. So any questions or comments on the WebAssembly stuff here? I've added the link to the announcement as well as the repo, both in the chat and in the document, so in the agenda, so that folks can check it out. And then, we can have a follow-up conversation after people kind of review it.
Not on the OCI stuff specifically, but while we're talking about WASM, we've just merged support for Istio 1.7 WebAssembly Envoy filters into master this morning, so we should get a release out either today or tomorrow morning that will officially support Istio 1.7, which I know has been a big thing the community is looking for. So we're excited to get that out pretty soon. And then also we're getting really close to having full official Rust support for WebAssembly modules, which is really exciting and has been another big thing that's been requested by the community. So we're stoked to be working on that too.
Yeah, that's exciting. Shane, so in Istio 1.7, is the WASM module being loaded from HTTP, or how's it being loaded?
So there's basically two options. So we have a WASM operator image, which will run in the cluster that will basically handle interaction from our WASMI CLI. So we've built a CLI called WASMI, which is used to interact with all these WASM images using our OCI spec, and it also talks to our WASM Hub platform, which is WebAssemblyHub.io. And that's our online cloud service that is free to use, and you use it to push and pull images down that have these OCI images of WebAssembly modules. Specifically right now, a lot of people are using this for Envoy filters in both Glue and Istio, and also just I say default Envoy, but right now it's actually still a fork called Envoy WASM, but they're hoping to upstream it really soon, hopefully. But yeah, so we can either do it via our WASMI CLI with a just simple, I think it's WASMI Istio deploy, and then you can get your filter right out onto whatever namespace you've got tagged for that, or you can actually use a Kubernetes CRD called Envoy filter, and that way you can do it in a more declarative way, and that'll end up pulling down your filters into the cache from WASM Hub and deploying them into your deployments.
Okay, gotcha.
Cool, thanks, Shane. And
Yeah,
I
no
added
problems.
I added the coming soon stuff to the notes as well. So, and then we can update that when those are out. Let's see, next, if we have no questions or comments there, next we can go to Joe to provide some progress on Service Mesh Hub on the AWS App Mesh side.
Yeah, for sure. Before we dive into App Mesh a little bit, just to give kind of a broader project update on Service Mesh Hub. Over the last couple of weeks since we last spoke, we've merged a handful of like smaller fixes, docs fixes, bug fixes, and we've also added support for Istio 1.7 through our demo flow. So if you've been testing out Istio 1.7 through Istio CTL 1.7 on your own machine, now you'll be able to do the same with Service Mesh Hub and our Istio multi-cluster demo command. And additionally, in terms of new functionality that we've added recently, we've just merged in the ability to do subset routing on our own failover services. So you get a little bit more granular control when you're working with those. But the larger initiative that we've been working on is App Mesh support in Service Mesh Hub. Scott has worked on a lot of the groundwork there and kind of like the overall design. The approach that we're going with is like expecting that users will be using the official AWS App Mesh controller for Kubernetes to manage all of their different App Mesh objects through CRDs and through that controller. And like doing so will allow us to have the Service Mesh Hub controller to continue working in this declarative scheme where the input is CRDs and the output is CRDs, so that our like kind of overall system design can stay in place and stay predictable. As we kind of build out this App Mesh support, you can expect the same discovery and networking design to apply here. So we'll have discovery running against these different different clusters where we see the App Mesh CRDs, and in doing so, we'll be able to discover injected workloads and the various App Mesh meshes could be one or many that are being managed by controllers running on registered clusters. We will also be providing some traffic policy features. We're targeting timeouts, retries, and traffic shift in this kind of initial push. App Mesh isn't quite as fully featured as Istio, but as features are added and as we're able, we will try to maintain feature parity with like the full extent of the Service Mesh Hub API on top of these kind of App Mesh primitives. And then like down the line, kind of like a next step feature that we will start investigating is going to be adding the ability to define the network edges within App Mesh. App Mesh doesn't have the same kind of strong guarantees of MTLS and access policy as Istio, but it still has the ability to determine which services are allowed to communicate with one another. So we will look to leverage that, maybe not in our own access policy APIs, as to not mislead users into thinking that they're getting those same security guarantees, but perhaps in kind of like a sibling API that will allow users to define those network edges through our API. And in the community meeting doc, I added a couple of links here. One talks about, one is a link to the documentation for the AWS AppMesh controller to learn a little bit more about that project. In my experience so far, it's been much easier to manipulate AppMesh objects through those CRDs compared to kind of like wrangling the various API objects that one would have to manipulate on their own, kind of outside of that declarative system. And there's also a link to the components and concepts documentation for Service Mesh Hub, so that you can kind of see what to expect in terms of like input and output and how data will flow through the system for AppMesh, because it's going to be fairly similar to our Istio design.
So Joe, for some of the things you just described that you got accomplished, they would be in that concepts more or less. Is that the right place to look to understand the details behind some of those bullets?
Sure, yeah. So the concepts documentation that I linked to there is more about kind of like the code architecture of Service Mesh Hub. So it kind of describes our reconcile loop from like input being, say, Kubernetes services and some of the like raw mesh, or yeah, Kubernetes services, workloads, and other kind of like injected resources. And then the output being like the API objects themselves. So in Istio, like, you know, virtual services and whatnot, and in AppMesh, you have virtual nodes, virtual routes, virtual gateways. So I linked to that doc to say that the like kind of AppMesh design is going to be very analogous to the like Istio design that we have in place.
Oh, I see. Yeah, because that's just that's the concepts that's been there for a while. So so some of the documentation around how the AWS objects relate to this, it's still pending, I guess, is the summary.
Right, exactly.
Right?
Yep.
Okay.
Cool. Any other questions, comments?
I guess one sort of question on that. You mentioned that they don't have MTLS support, but I think they're in the process of working that. Do you have a visibility into how they're going to do that, and whether it's going to affect your APIs much, or is that still kind of waiting to see what they come out with respect to that support?
No,
yeah,
we do have some insight to that. Oh, go ahead.
No, go ahead.
I was going to say we do have insight into that, but I'll let Joe and engineering speak to where we are with that. But yeah, we're working with AWS on that.
Right, exactly. Like, since that is kind of an ongoing development, we are focusing more on like the traffic policy side of things before we get into like the MTLS and access control.
Okay.
All right. And let's see. So next up, we have Celso on the community meeting to talk a little bit about the work that he did for Glue on ARM. I think that'd be fun. So if you can give talk a little bit about it, that'd be great.
Yeah, I think it's okay if I share my screen. Just, I don't know if this even has access to it. So yeah, as I would guess, Zoom doesn't have access to the screen share. Doesn't matter. Essentially, this was something that started out.
So I just made you a co-host.
No,
So
no, I think it's actually the permissions on the system or something like that.
Oh, weird.
Max,
okay.
Max and all their permissions. But essentially, this was on one of those projects that came out of boredom and frustration during quarantine, and I've been kind of trying this idea of having a Raspberry Pi cluster, which is pretty common setup, and also to use that one as my old kind of lab for personal use and professional use, because we are developing on the company that I'm working at, we are developing with Glue. So this quickly took me to the realization that, okay, we're not quite there yet. There's no support for ARM for the ARM on this. And of course, this took me down the rabbit hole of trying to understand where exactly does this issue lie. And it was pretty apparent that Envoy was already building the ARM support. So if Envoy was already building it, we should probably be able to take advantage of it and also use those versions to build something that would run on that architecture. Turns out the issue is not quite as easy. There are a few dependencies here. Okay, the Envoy build did work on ARM, but Envoy Glue, for instance, had a couple of dependencies. One on the Alpine glibc image, which turns out it's not also built for ARM64, and even that one had a dependency on a package from another repo, which I'll be happy to share afterwards. That provide the binaries required to build this Alpine glibc image. Of course, again, no ARM support, so we kind of had to build the whole stack. So from building glibc to ARM64 architectures, then we had to produce an image that would replace the Alpine glibc also for ARM64, so that we can then build that into Envoy Glue. So the changes were made mainly for those specific reasons. And afterwards, in terms of Glue itself, it was mostly about changing access to the way that the builds are made. So we had a bunch of hard-coded references to AMD64 images. It was mainly a matter of introducing a new variable during build time, which defines the architecture. We can probably share the PR on the doc for the community, but that was mainly the work revolved around the build process and making sure that all the dependencies in the stack to get Glue to build on ARM64 images would also be supported and available during this process. I don't know if there's any questions regarding this. We're still, of course, not releasing ARM64 images yet. There's still a bit of work to do there, namely on the build pipeline. We had a brief discussion around this on Slack, and we're thinking about probably using S1 instances on AWS, because I think those are ARM64 instruction sets that will allow us to release Glue.
That sounds pretty awesome. Thanks for digging into that.
Yeah, it was not as easy as I would like it, but again, it was actually pretty fast once it was. We had all the dependencies. It was pretty fast to do it. There weren't really not a lot of changes.
How has the experience of running Glue been on that ARM architecture? Like beyond building it, but like interacting with it?
If I want to be 100% honest, other than making sure that it was running, I really haven't had the time to really get back to it. I'm actually right in the middle of the process of building the cluster now that I got all the parts. So I should be performing some more testing around the end of this month, I hope. And I also believe there are still a couple changes that we're going to need to make to Envoy Glue before we can really start releasing those images.
Gotcha.
I think we'll, by the way, also Envoy itself, it's not yet releasing official ARM64 images. only on the Envoy dev channel, but it should be pretty soon. And I think we should probably wait until then before focusing on that.
Any other questions or comments? Looking forward to the progress. So you said end of the month, and then we can check back in.
Sure, we will.
Yeah. And then, so if there are no additional comments to that, let's see. The thing we can do is now we have Mihai. You want to, if your audio is good, I've got you on as the last to give an update on some progress.
Yeah, can you hear me okay?
Yep.
Okay, so we've been, this is part of the limited trust discussion. After some internal reviews and some meetings we had, we came to the conclusion that the fastest and best approach to get this right now is the approach you guys described for limited trust, basically using an Ingress Gateway to create another shared trust domain between an ingress and the egress, and not modifying the trust domains inside each cluster. So we've recently started working on that model. From what I can tell, there should be, I think we need 2 external API changes for that to work. One of them is adding the egress gateway as information in the Istio mesh. It's currently not there. You only have the Ingress Gateway. And another one is that the limited trust model in the virtual mesh is basically an empty interface. It has nothing related to how to get certificates into a virtual mesh using limited trust, as far as I can tell. And in order to get that to work, we were thinking of trying to get the certificate agent, instead of pointing to IstioD to issue the certificate and modify the certificates there, to see if we can get it to point to the ingress and egress gateways and just modify the certificates on those workloads. Does that sound okay to you guys? What do you think?
Can you restate the last part there where you said, so instead of pointing to IstioD, you want to point to the Ingress Gateways? Which certificate? Can you give a little more detail on that?
Okay, so Istio supports configuring TLS origination and TLS termination on the Ingress gateways. I believe it does that through some secrets that you can configure. What we want to do is not change the trust domain inside each cluster for inter-mesh communication. We just want to have intra-mesh communication. We just want to have a trust domain be established between different clusters. So the first thing we want to do is not modify the certificates in Istio, so that whatever is configured by the client inside the cluster does not get changed. And another thing we want to do is leverage your current infrastructure for generating certificates, but have it configure just the secrets necessary for the ingress and egress gateways in order to establish the shared trust between different clusters.
So in this model that you're attacking here, the trust domains are different and they're anchored in different root signing certificates.
Yeah, exactly. And then you have a third trust domain. If you have 2 clusters, so you have trust domain A for cluster A, trust domain B for cluster B. Then you have a third trust domain that's between A and B. This does have the problem of losing identity, but it also solves the problem of having to tamper with certificates in clusters to get them to talk with each other. What we're trying to do is basically have the ingress and egress do TLS termination and origination and forward the packets to their own clusters. I believe it's the same thing you guys described for limited trust.
Yeah, okay. Makes sense.
So, I mean, I think at some point we want to explore maybe other trust models. I think we talked about that a little while back, that there's probably a number of different trust models that one can have, the shared root, or what Mihai just described, or even some things like Istio is describing with SPIFFE Federation and trust bundles and stuff like that. So probably something that we maybe want to explore more holistically, but I think for now we decided that we just wanted to get something going, get something in front of you, follow the model that you already have, so that we can quickly get that in there to you know, experiment with it and move forward.
Yeah, that makes sense. Okay.
That's also partly why I was asking about where AppMesh is going with MTLS, because they might have some of their own models of how you federate trust across clusters. So that's why, you know, there might be an influence with what they end up supporting there that might influence how we want to approach this.
Makes sense.
All right. Is there anything else? Any other questions or comments or things that people would like to add? We've gone through all the items officially added to the agenda.
I'd like to add that I'll probably be stressing some of you out on Slack in the following days. With regards to this, if that's okay.
Awesome. All right, so if there is nothing else this time around, we've got all the links and stuff in here for folks if you want to refer back to the various PRs or repos and such with more information on the things we talked about today. And then we will see everybody in 2 weeks.
Sounds good. Look forward to it.
All right. Have a good day. Bye.
Okay, thanks. Bye.
Thank you. Bye.